We have three presenters. First up is Brandon Eckstorm. He is the product marketing manager for the entertainment industry here at Vectorworks. Second up is Rene Berhorst. He is the head of product management at MA Lighting. And then thirdly, we have Matt Geasey, technical director at Clear All Visuals. So with that in mind, I will turn it over to Brandon now, and he's gonna take us through the intro.
Hi, everybody. Sorry my webcam's not up in person, but from my location, I don't exactly have the internet speed to get a good webcam or good audio, so I chose doing the audio. So just to give you a little bit of a background of where we are at with GDTF MVR integration as far as it goes with Vectorworks and Vision. With the SP3 release of Vectorworks, we started to implement our first round of GDTF information. So now as you have a fixture, you can actually assign GDTF mode to the fixture. Right now, we're not bringing in geometry from the fixture just because it's not working yet with our rendering engine. We are working very diligently to get that updated with our rendering engine, so we'll be able to pull in the geometry as well and have that in your file. But for right now, we're just pulling in the data. We're not getting rid of any of the geometry. It will pass through with the file. Vision does accept the GDTF geometry as well as all the functionality. Rene, if you want to go over any of your stuff as well.
Yes, I'd love to. So with the GrandMA 3, we have fully implemented GDTF, of course, and MVR. So we read all of the data from GDTF, but to be honest, we're not displaying all of it yet, but that's work in progress, of course. Yeah, and the same happens for MVR. You can just import an MVR file and of course, most probably see it in the 3D window, but also in the patch window, and change data and export MVR again so that whoever reads in MVR can read the changes as well.
Nice. I saw a question here from Weston about the geometry. So yes, the actual physical 3ds file is stored in the background in the Vectorworks document, but it's actually not going to be displayed in the drawing. Right now, it's only going to be associated with the fixture. If you import an MVR file and it doesn't have, and that symbol hasn't already been in the document, we're just going to put in a rectangle for right now. So I kind of wanted to show a little bit about how the GDTF fixture builder has kind of evolved and where it's at right now. So Tyler, if you want to show the next slide, we have a little bit of a video. So this video right here is just a quick overview of the fixture builder in its current state. So what we're going to do is we're going to grab a light, and this is going to be a GDTF file that I downloaded from the GDTF Fixture Share website, and we're just going to dump it in. So we have a mega pointy, so you can see all the manufacturer information, what is its names, its unique identifiers, and all the information about the fixture. And the next section we have in here is the geometry section. Here you're going to be able to see all the different parts of the fixture. And you can see this is all built out of 3ds. So you have this base, you also have the yoke, you have the head, and then you also have the beam. This is the lens area, and this is what actually emits the light from the fixture. So you can see the lens there. And you can see over, you also have all the different properties and everything. And we even have the tail. We have the emitters for the fixture, and then if there's any filters, so there's like a magenta flag, a cyan flag, and your yellow flag. For color mixing, all the different wheels that come in it. The gobo wheel, you can see all the images of the different gobos. Down lower, you can see the color wheel with some of the colors, another gobo wheel with some more images, the animation wheel, and prism wheel. So there's some images of what the prism looks like and all the different facets. You can kind of see how those are built out. When you get all of this stuff built out, we go into the DMX section. So you can see all the different DMX controls and what each parameter does and how it controls the lights, anything that might be a default preset that you're going to ship with the fixture. For instance, like Gobo 1, what is its DMX value, or the third color on a color wheel, what is its default value? That's where all this information is going to be placed. You can see all those here in this macros wheel, or this internal wheel. After this is a macro section where you can add macros. Right now there's no macros listed in here. And then finally, we will get to the summary, which is just a basic overview of everything that the fixture does, all its different information, things, how the DMX is laid out, and just general information for you. And with that, I'm going to go ahead and turn it over to Matt.
Hey everybody, how are you? My name is Matt Geasey, just in case whoever's on here that doesn't already know me, which there's a lot of you here, holy cow. Nice to meet everybody. So we have been utilizing GDTF and MVR in our workflows and learning about it the best we could with the information that has been present and available online to make things more efficient and really understand what it could do for the entire industry as a whole, not just for certain parts of it. Just in case there's some attendees on here that don't know, GDTF stands for General Device Type Format, and then MVR stands for My Virtual Rig. The biggest difference is GDTF is a container file that is specifically allocated or designed to represent any device in a show, project, anything that can be, you know, a video screen, that can be a media server, it can be a lighting device, it can be a special effects device. The key word is device here. The goal was to not have it just be for lighting only, as in today's world there's a lot of things that can be controlled through many different platforms, which is great. My Virtual Rig is another container file that contains your entire project, everything that is in your scene, or that is in the drafting program, or the previs software, or the lighting console, or control surface, it doesn't matter. It is ambiguous to anything, as it is a massive container of all the information. And the relationship between GDTF and MVR is GDTF files are contained inside the MVR file once it is exported or imported. And it's now a resource that in turn has more resources about its specific information that can be used by any program out there, application that wishes to use it. And so going to the slides now, I just put together a workflow that we've just kind of used as our base scene for whenever changes come or we learn something new, we add it into our entire project here. So starting here, we're just starting in Vectorworks, and my workflow is we utilize the Granime 3 control surface a lot, and we utilize Vectorworks a lot with numerous visualizer platforms. As you know, it's important to know a lot of different visualizers in our world because some do things better than others, and some people like others versus others. You know, everything has an advantage. But in this presentation, I'm going to be showing all of the current applications that do have MVR and GDTF implemented to my knowledge. And I'm sorry if there's some out there that have it and I just haven't gotten there yet, so I do apologize. But starting here, this is a very, you know, basic, we'll call it a festival rig, I guess, you know, a couple of straight sticks, you got some lights, some fun. And it has a stage that was brought in that we used from Vectorworks, the library in Vectorworks, SAM 555. GT Truss brought in from Vectorworks, utilizing the Truss library. And then these are custom GDTF files that we have built of a GLP Highlander wash, a a K&V cube, and the, was that an X4? Yeah, the impression X4, just for our examples here. So here, this is just our starting scene. You know, if you're starting in Vectorworks, this is kind of where you would get to. And then in the next slide, we can move on, Tyler. Sorry, I'm not driving this either. It was easier for me to let Tyler drive this. So here is just a worksheet showing what information I actually entered into the lighting devices for Vectorworks. To get this information, what we did was, you know, we imported our GDTF files going through the proper Vectorworks way, you know, file, import GDTF. And now those files are available in your project to then be assigned inside the lighting device object info window, which is great. I purposely did not assign any universe or address information for patching. All I wanted to show was that we only have channel information right now. So then we can move to the next one. So from that file, we used the export MVR function, which is in the, you know, file export MVR, and you take your container file, and now this file can go anywhere that accepts MVR. It's really fantastic, actually. This was a straight up import of just a single file into Vision. And to do that, it's, you know, as simple as file, open, and you open your MVR file, and everything comes in the way it's supposed to. As you can see here, this is exactly what our scene looks like inside Vectorworks. And what it's doing is, inside the MVR file is a full 3DS file of the stage, 3DS files of the trussing. You know, like Brandon said, Vision is utilizing the geometry from GDTF files. Now, not all applications decide to use the 3DS information because they already might have their own one that's already done, which is totally fine. That's great. You know, but there's a lot of other useful information inside the device that I think would be useful for a lot of visualizers out there. So this is the MVR in Vision, and keep in mind, this is going to be the same file that we have been using, passing back and forth. There's been no duplicates, no copy paste, no going into the XML and editing it. This is all in and out for the next couple of slides. So on the next one, I believe we are showing, let me catch up here. Yep, so we're showing that the information inside of that file is still intact the way it's supposed to be. And the biggest thing to remember in the relationship between MVR and GDTF is that all of the fixture ID information, the patch information, what it is, all of that is stored inside the MVR file. It is referencing a GDTF file that is now traveling with that back and forth. Those, you know, it has a bunch of information. And the biggest thing to remember about GDTF files is that they are not a fixture profile. They are a container file that do contain modes for lighting, you know, for the lighting side of things, of the DMX tree that exists for different modes of them, which is awesome. So you can see that we are using, yep, yeah, this is just sorry, the Highlander wash doesn't have any modes, it just has the normal mode. But if we had the X4 in here and we utilize the extended mode or the high res mode, it would show up, you know, what mode it's actually pulling from the GDTF file and utilizing that information inside of it. So then on the next slide, we will be showing this same file, and this is into MA3. This is into the 3D window of MA3. You know, same file, same thing. I had a UV backwards on one of my screens. I apologize about that. That is bad on my end. But showing what it is.
We are very serious on UV mapping.
I broke the rule. That is my fault. So this is the same file. Everything looks exactly the same, minus shaders, GUI information, that's all program specific or application specific. But this is still the same file and all the same information being read correctly into the MA3 platform now, which is great. And then what we can show is we can go into the next slide that shows the information that's actually being utilized currently in MA3 and what they're pulling out and what they're using. You can all the modes, layers, class information. You'll notice that in this one there is a patch, and I apologize about that. I think I messed up that slide, but that is my bad. There's currently a patch in here. This was after I got futzy with things. Anyways, there would be no patch information coming into this, which actually gets shown in 2 slides later. But the next slide is showing from Vectorworks how it's utilizing the appropriate layer and class information. And it's coming in and now being stored and accessible into the MA3 console, which is great. What this also means is that I can now utilize these same layers, and when this MVR file gets re-exported, we're not creating duplicate layers. We're not creating more information that is not needed. We are utilizing information that was set by somebody in the project that determined how things are going to get laid out, how things are going to be used, and everybody can play by the same rules and play in the same sandbox instead of things getting, oh, where did you put this? Well, I put it in a new layer called, Trust 3. Well, we already have a layer called Trust. You don't utilize the Trust layer. It's already there for you. To keep things organized and everybody on the same page, which is great. So now on to the next slide this is the actual MVR file that came in before I patched it. So this is the way it looks. There's no patch information. We didn't have any inside the Vectorworks file, which is good. That's exactly the way we should read it. And it's pretty self-explanatory, pretty simple. Now on the next slide, we're actually going to patch the console, and from here we will export this as an MVR file. Now the coolest thing that I really like about utilizing MVR is everybody works differently in different programs. Some people are faster in one program than another. For us, we are more efficient to patch out of the console. I'm not very fast at going to patch inside Vectorworks. I'm just not good at it. So what I do is I actually patch all of our shows inside the MA3, and now I can take that information, put it into the new MVR file that is for everybody to use, and everybody's up to date. Re-import the file, awesome, done. And we're actually doing that on the next slide. We're showing an MVR import now back into Vectorworks. And you'll see on the worksheet that we now have all of the universe and address information that came in. The scene looks exactly the same, nothing changed, it didn't break anything. All those relations are still present inside Vectorworks, which is fantastic. And it would go for the same thing of any other application that utilizes MVR information. They've done a very, very good job with making sure that UUIDs are used correctly for each individual piece of information inside the entire scene, so that nothing gets, wacky. I'm not saying that it can't get wacky, software bit flips, things happen, but, the potential for things to really get messed up on a really large project is much less, unless somebody doesn't follow the rules in another program and, just breaks it. That's out of our control. So on the next slide, we're showing the same thing coming back into Vision. And keep in mind, this is still the same MVR file that we exported out of the MA3 now. So we started in Vectorworks, gave it the information that we knew, exported the MVR, saw the information that it did, changed some things inside the MA3 now, and now we re-exported the MVR as a new working MVR for the entire project. and we're bringing them into all the programs that would now need this information. And you can see that now there is a universe and channel patch information as well inside the fixture that didn't have any before from inside Vision, which is really, really awesome. And it goes back to everybody being able to play in the same sandbox. Right now, there are tons of different ways to put projects together, tons of different ways to, get information from one program to another. Some work, some are more of a pain in the butt, some require, a lot of tedious work. Case in point, if you're taking a DWG out of capture right now, it takes some time to redraw some things and just get it to where it needs to be so that it's really clean and simple for the end users and the PDF decks that are getting built for them. But say that they had MVR implemented, all they would have to do is now send an MVR file out, and anybody can now utilize this information. It's great. It would go into any accepting platform that can utilize, that implements MVR. And that's the really exciting part. There's no, oh, well, where do I start? As long as it originates somewhere, that's the only thing that matters. Like I said, we're using Vectorworks because that's our workflow. We love it. It's great. But we could have easily started in, let's see, what other? I'll just use Depence as an example. I know that they import MVR, and I'm actually showing that on the next slide. So Depence, the software visualization, they utilize importing MVR. I don't know about the exporting yet, but we can go to the next slide, Tyler. Sweet. So this is what happens in their world and how they have decided to implement it. And I think it's a really, really nice way that they've done it. So Depence is not using all of the information from the GDTF files that are in the MVR file, which is perfectly acceptable. There's no one saying that you have to use GDTF files. There's no rule saying that you have to utilize the information, all the information in it. They've already, inside their software, they have their way to make their software run efficiently and do things and optimized, and nobody wants to break that. That doesn't make sense. That's more work now for them to have to do this. But what they did was they found, they made an interpreter that allows them to sniff out the GDTF files that were used and match them to their internal library. Fantastic. Kind of like when we do a WYSIWYG import, you can do a CSV file of all the fixtures wherever it came from. And then inside theirs, you interpret what fixture inside their library this should already be. And it's fantastic. So on the next slide, we show us, we can take in the MVR file, and it's identical again. All the same information is there. It's done. No setup, no nothing. Now this contains all the information from Vectorworks, the adjustment inside MA3, and now it's all in Depence. And that is the goal. It's a waste of time to redraw things over and over and over, depending on what the client wants to use, either in a visualizer or a console or numerous other things. It doesn't make sense in today's world. There's a lot of kind of different sandboxes that are floating around each other, but the MVR file allows everybody to play from the same sandbox. They don't have to utilize everything, but they can pick and choose what they want out of this information. And to me, that is the powerful thing of MVR and what it is as a big container file of information for a lot of people. I can really see MVR turning into a much larger thing to where there could be a service that, like a cloud service, you have a master MVR file for a project, and you can keep updating that same MVR file, and now everybody can pull down from it. you know, that is a really, really awesome way, I think, to utilize this information. And it goes down to like our concept of, I firmly believe that everybody should know everything about the project. You know, not like, oh, you know, video shouldn't really know about this, they don't care about it. It's like, no, maybe they care about it, who knows? They should know all of this information. You know, audio could be an example. When they're building out their scenes, if they need the stage and where things are going to be, and you know what set pieces are where and how they're going to lay things out, all of that is inside the MVR file. All they have to do is read it. You know, so it could go multiple ways, and it's just about accessing the information that is given. And we firmly believe that, you know, that's why we're utilizing 100%, because we can send this file to anybody and they can use the information instead of going, oh, well, you didn't send us that. It's like, it's in this file, use it. If you choose not to, that's on you. I'm sorry. So I think we go into, yeah, so now we can talk about GDTF a little bit and touch on it. And at the end of the day, the GDTF side of things, it's the container file for devices, any device. Kind of saying what I did earlier, it's not a profile. It is not a fixture profile. You know, it was, you know, when Roby, MA, and Vectorworks all came up with these ideas and the implementation of them, they didn't look at it from a single use of, oh, it's only going to be used in Vectorworks, oh, it's only going to be used in MA, oh, you know, Roby's just going to build their files like this. No, that's not how it was thought about. It was the overall idea of giving the correct information to people to utilize how they would, you know, how they need it, so that the right info is interpreted all the time. And for GDTF, for us, it's very, very big, because right now anybody can build anything, and that's great. There's nothing wrong with that. But is it correct from the manufacturer of that device? Maybe yes, maybe no. You know, it happens. So going into this, what we have a GDTF file that we built for the ColorForce 272. Tyler, we can go to the next slide. Sweet. So if anybody's familiar with this fixture, it has 180 different configurations of DMX. That's a lot. That's insane. But it doesn't matter anymore. You know, in the current workflows of today, this would mean every console, every visualizer, every, you know, CAD software, anything that utilizes this fixture would need 180 different things of it if a DMX mode was attached to it. That is insane to keep track of. That doesn't make sense. Like, that is super inefficient at the end of the day. I'm not going to carry around 180 different profiles on my USB stick hoping that one of them matches the festival rig that I'm going into. Doesn't work. This is my favorite thing about GDTF, and it is the collection of all the DMX modes for lighting at the end of the day, on top of information across the board for numerous other things. You know, so now this one file has every piece of information that you could possibly need about it, and you can choose what you want from it. It's fantastic. Yeah, 180 modes, that's a lot, but you know, that's how it was built. So on the next slide, I don't know how many people are familiar with Unreal Engine. Unreal Engine does utilize GDTF as of their most recent release, 4.25. And it's really cool that a software like this that has very little to do with the lighting side of things inside entertainment, you know, they do a lot of, they're very involved in film, very involved in the entertainment sector as a whole. But the mere fact that they utilized GDTF to get information about these devices is huge in my mind. You know, it all goes back to everybody having the same information at the end of the day from the manufacturers of these devices. So on the next slide, I'm just showing a quick little overview on what they're, you know, what they're looking for and how they laid it out. And this is, you know, it's showing that, yes, this is the Highlander wash, you know, this is the manufacturer. Here's the ID of it, you know, which is its specific UUID that was given to it from the manufacturer when it was built. And it has DMX information in it. It has, you know, patching information. It has all the necessary, it's pulling all the necessary information that the Unreal Engine is actually looking for and wants to utilize out of the file. They don't want the geometry. Cool, no big deal. You know, they don't need it. That's not what they're looking for. They're looking for DMX information. They're looking for mode information. They're looking for, you know, color possibly at the end of the day. I didn't get a chance to really dig in too much with it yet, but the information is there if they want it, and it's awesome. I can't say enough good things about, you know, the reason that GDTF was created, and the fact that you're getting all the information from the manufacturer about their device, and it's great. Yeah. So that concludes just, you know, our workflow and how we're doing things and stuff like that. And I guess, Brandon, it's time for questions.